Hey guys! Welcome back to the laboratory. In this video, we are looking at alkanes. By the end of this video, you should be able to define the term alkane, describe the main features of a homologous series, and explain why alkanes form a homologous series. So, let's go. The alkanes are a homologous series of hydrocarbons that have only single covalent bonds between the atoms in their molecules. A homologous series is a family of hydrocarbons that share a number of similarities. For example, the alkane family have the same general formula, show a gradual variation in physical properties, have similar chemical properties, and the molecular formula of each neighbouring alkane differs by CH2. Let's take a look at each of these in a bit more detail. The general formula is a simple expression of the ratio of each type of atom in a compound. A bit wordy, I know, so let's look at this concept in practice. The general formula of the alkane family is CnH2n plus 2. This means whatever value of carbon atoms are present in the formula, the value of the hydrogen atoms is twice that value plus 2. Any hydrocarbon that does not follow the rule of this general formula does not belong to this homologous series and is therefore not an alkane. For example, methane, which is the first alkane in the alkane family, has the chemical formula CH4. The number of carbon atoms in this formula is 1. 1 multiplied by 2 is 2, plus 2 is 4. The chemical formula for methane follows the general formula of an alkane, and therefore belongs to this homologous series. Butane has the chemical formula C4H10. The number of carbon atoms in this formula is 4. 4 multiplied by 2 is 8, plus 2 is 10. The chemical formula for butane follows the general formula of an alkane, and therefore belongs to this homologous series. However, ethene has the chemical formula C2H4. There are 2 carbon atoms in this formula and just 4 hydrogen atoms. This chemical formula does not follow the general formula of the alkanes, and so must belong to another homologous series. As well as having the same general formula, the molecular formula of each neighbouring alkane differs by CH2. Let's demonstrate this looking at ethane, methane, propane and butane as our examples. These are the first 4 alkanes in the series. If we look at the molecular formulas for ethane and methane, we see that methane has 1 more carbon atom and 2 more hydrogen atoms than ethane, therefore differing with its neighbour by CH2. Now we can look at propane with the molecular formula C3H8. Once again, we see that propane has 1 more carbon atom and 2 more hydrogen atoms than methane. The same is seen when we compare the molecular formulas of propane and butane and continues onwards. So, here's a question. What molecular formula would pentane, the 5th alkane in the series, have? If your answer to the question is C5H12, then you're spot on. There are several trends in the physical properties of the alkanes as we move along the series. For example, as we move down the homologous series, the number of atoms increase and thus, so does the molar weight. As the number of atoms in the alkanes increase, the melting and boiling points increase too. This is because of the increased number of intramolecular forces within each alkane, therefore requiring more energy to overcome and change the state of the substance. As well as having similar physical properties, the alkanes react similarly in chemical reactions too. For example, when the alkanes react with a plentiful supply of oxygen, the products of the reaction are carbon dioxide and water. Here are the equations for the reactions of methane, ethane and propane with a plentiful supply of oxygen. Here's an example of a past paper question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Propane C3H8, and butane, C4H10, are members of the same homologous series, called the alkanes. Explain why both propane and butane are alkanes. This question is a nice, straightforward one. If butane and propane belong to the same homologous series, the same family, then what features relate them? There are more than 2 answers you can give for this question to achieve the full marks here, all of which we have discussed in this video. So, if you mention that they both have the same general formula, give yourself the mark here. If you mention that they have similar or the same chemical properties, then that is worth a mark too. A mark is also awarded for stating that they are both hydrocarbons, that neighbouring molecules differ by CH2, and that they both contain single bonds only. The second half of this question asks for you to draw a molecule of butane, showing all covalent bonds. This question is generous and has provided you with the chemical formula of butane. We know that alkanes contain single bonds only, and we should know from our previous video on covalent bonding that carbon is in group 4 and can therefore only form a maximum of 4 bonds at a time. We can now apply this all to draw our molecule. The correct diagram should look like this: 4 carbon atoms, 10 hydrogen atoms, each joined by single bonds only. So, how did you do on these questions? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!